On October 6, 2008, we discovered a near-Earth asteroid about the size of a Volkswagen, and we determined that it would hit the Earth's atmosphere at 7:46 Pacific Daylight Time over the northern Sudan region of northern Africa. And at that location, of course, it would be 4:46 in the morning in the pre-dawn sky. Well, it was discovered the way these near-Earth objects are always discovered. We take a CCD image, just like you would with your camera, of a certain region of the sky, come back to that region 15 minutes later, take another image, come back to that same region 15 minutes later, take a third or fourth image, and then we compare the images to see if any of the objects in those images have moved. And if they have, they're almost certainly near-Earth objects. These objects are tiny and they're dark. And because they're tiny and dark, they're very, very faint. And we can only discover them when they're fairly close to the Earth, when they're not nearly as faint as they usually are. So when they get close to the Earth, they're easiest to discover. Their motions on the sky are fastest. And so that's the time when we typically discover near-Earth objects, when they're fairly close to the Earth. Why are we so confident this object, the size of a Volkswagen, is not going to punch through the atmosphere and hit the ground? Well, what happens is that most of these objects are stony objects, and what happens when they reach about 30 miles into the atmosphere coming down, the pressure on the front side of that stony object is so much greater than the pressure on the back side that they pancake and fragment and dissipate into the Earth's atmosphere. And so what you see is a fireball event or a bolide event, and this object fragments into a bazillion pieces and then simply dissipates or burns up in the Earth's atmosphere without any of the fragments reaching the ground. Well, this is a discovery that's big on a number of points. First of all, it's a prediction of a very bright fireball event, so people can go out there and set up their equipment and get ready for it, whereas usually a fireball is observed by people who just serendipitously are looking up at the right time. So now we have a prediction suggesting when this will occur. So this suggests that the telescopic surveys that NASA has in place, the orbit computation and impact probability calculations that NASA now has in place are working rather well, because we were able to discover and predict exactly where this object would hit in a matter of a couple of hours and get it out on the web to the folks who need to know. So I'm pleased that the system is working so well. It just shows that NASA's ability to discover and track these objects is getting better and better, and that's exactly what we need.